Hello, for today's video lecture we're going to be talking about Newton's third law of motion. So Newton's third law states that for every action there is an equal and opposite reaction. So though the term action is applied to many different things, Newton originally meant a force when he said action. So for every force there is an equal and opposite force. And that's how it is applied in engineering and mechanics, is for every force there's an equal and opposite force. So this law means that all forces come in pairs. This is a Newton's third law pair, as we will often talk about it. So if body A exerts a force on body B, then body B exerts an equal and opposite force back on body A. So it's important to note here that a Newton's third law pair has to act on two separate bodies. You can't have a Newton's third law pair acting on a single body. One force has to act on each of the two bodies that are interacting. So some examples of some Newton's third law pairs: we have the Earth and the Moon. Both of those are going to exert gravitational forces on one another. So the Earth pulls on the Moon, and the Moon is going to pull back equal and opposite on the Earth. For a box sitting on a table like this, we're going to identify some of the Newton's third law pairs. So first we have the gravity force. So the gravity force, the Earth is pulling down on the box. If we were to look at the Earth would be pulling up, the box would be pulling up on the Earth with an equal and opposite force. It's just that the Earth is so much more massive, we don't notice that force from the Earth's perspective. So also to look at this, so the box is going to be pushing down on the table. So it's a normal force exerted down on the table. And the table is going to exert an equal and opposite normal force on the box. So this normal force, anywhere we have contact, we're going to have an equal and opposite set of normal forces there. And some other types of Newton's third law pairs. So say we've got a pin joint attaching a beam of some sort to a wall. If we were to look at these two pieces, so I've separated out the pin joint and the beam, and this often happens in structures. We're going to see, assume we have some sort of reaction forces. So I've got two reaction forces acting on the beam. If I were to draw the support, I need to draw those reaction forces equal and opposite. So the forces in the X are equal and opposite, and the forces in the Y are equal and opposite. Like I said, this comes up frequently in structures. Alright, so that's all we have for today's video lecture. Thank you for watching, and I hope to see you again.